Hello and welcome. Today we're going to continue our discussion on factoring polynomials by discussing another specific case of perfect square trinomials. First, let's recall what we talked about in our most recent discussion, factoring the difference of squares. Now remember, if you have two terms that are perfect squares with a subtraction sign in the middle, this is considered the difference of squares. I am going to rewrite my first term instead of as 4p squared as 2p all raised to the second power. And instead of 9, I am going to write 3 to the second power. I have two bases being raised to the second power. So to factor this, all I'm going to do is take the first, 2p, and add the second, 3. And then in my second parentheses, I take the first, 2p, and subtract the second, 3. Down on the left, I can rewrite 25n squared as 5n all to the second power, and instead of 16, I will write 4 to the second power. I have two bases, both being raised to the second power, and since I am subtracting them, I have the difference of squares. So I take my two bases, 5n and 4, I add them, and I subtract them. And last, I can rewrite my 9x squared as 3x all to the second power, and instead of 25, I will write 5 to the second power. Since I have the difference of two squares, I take the bases, 3x and 5, and add them, 3x plus 5, and subtract them, 3x minus 5. For a perfect square trinomial, when I factor it, I end up with a binomial raised to the second power. That is what makes this a perfect square trinomial. So when I FOIL this out, remember I cannot simply apply that exponent to both the x and the 4. I must rewrite my polynomial as x plus 4 times another x plus 4, and then FOIL out my polynomial. Distributing my x to the first x in the second parentheses, I get x squared. X times 4 is a positive 4x. Distributing my 4 times x is another positive 4x. And 4 times 4 is a positive 16. I'd like for you to notice I have two of the exact same term in the middle. So all I'm going to do is double that term to get 8x. And I have x squared in front and a plus 16 behind. This is the FOILed form of our original polynomial. Again, down to the left, I'm going to take my x plus 3 and rewrite it as x plus 3 times another x plus 3. Please do not simply apply that exponent to both things inside. You must rewrite the polynomial as two sets of parentheses. I distribute my x times x is x squared. X times positive 3 is positive 3x. And now when I distribute the 3 times x gives me another positive 3x, and 3 times 3 gives me a positive 9. In the middle, again, as before, you should see that I have two of the exact same terms, 3x and 3x, so all I'm going to do is double this to get 6x. I still have an x squared in front and a plus 9 behind. This polynomial is the FOILed form of my original. To the right, I am going to rewrite my expression as x plus 5 times another x plus 5, and will then FOIL out the polynomial. X times x gives me x squared. X times 5 gives me a positive 5x. 5 times x gives me another positive 5x. And 5 times 5 gives me a positive 25. Again, as in the previous two, you should see two of the exact same terms in the middle. So all I'm going to do is double this term, 5x, to get 10x. And I still have the x squared in front and the plus 25 behind. So this is the FOILed form of my original expression. So I'd like for you to notice for a moment the relationship between the ending trinomial and the original expression. My first term is simply the first term in my binomial squared. My last term, this 16, is simply the last term in my binomial squared. Now this middle term, this 8x, is simply double the 2 multiplied together. If I take 4 and x and multiply them together, I get 4x. The reason I have my 8x in the middle here is because I had 2 4x's in the previous line. So all I need to do is double this 4x, and that will give me my 8x. Let's check and see if this works for the other two. Here I have an x squared. That x squared came from my first term in my parentheses, squared. The last term in my trinomial, 9, came from the last term in my parentheses, squared. And this middle term is simply double the 2 multiplied together. So 2 times 3x. That gives me my 6x. To the right, my x squared is simply the first term in my parentheses squared. My 25 is simply the last term in my parentheses squared. And in the middle, I simply have 2 times the 2 things multiplied together. So 2 times 5x. So your rule: if you have a binomial being squared, a shortcut would be to take the first term in your parentheses, here I call it a, and square it. In the middle, we're going to add 2 times the 2 things multiplied together. And on the end, we add the last term in your parentheses, squared. So instead of foiling out this expression to the bottom left, I'm going to use the rule that I just wrote. I'm going to take my first term in my parentheses, which is x, and square it. I am then going to add 2 times the 2 things multiplied together, so 2 times 6x. All I'm doing is multiplying these two together and doubling it. I then add the last term in my parentheses, this 6 squared, so plus 6 squared, and simplify from there. X squared plus 12x plus 36 is your final expression. You would have obtained the same thing if you went through this foiling as we did in the previous examples. On the right, I'll do it one more time. Since this is a binomial raised to the second power, I may take my shortcut. I take my first term, which is x, and I square it. I then add 2 times the 2 things multiplied together. So here I'm multiplying x and 2, and I'll get 2x. I then add the last term, which is a positive 2, squared. Simplifying, I get x squared plus 4x plus 4. Go ahead and take a moment to pause the video and try these next 4 using the shortcut that I just showed you on your own. For the first, you should have taken your first term, which is 3x, and squared it. From there, you should have added 2 times the 2 multiplied together. Here I have a negative 6 times positive 3x. From there, your last term, you should have added the last term, which is negative 6 squared. So notice, when I multiply, my negative 6 squared ended up being a positive 36, and this middle term was negative. To the right, you should have taken your first term, which is 5n, and squared it. In the middle, you should have taken 2 times the 2 things multiplied together, so 2 times 1 times 5n, plus your last term, which is 1, squared. Down below, you should have taken your 5k and squared it. Your second term should have been 2 times the 2 things multiplied together, so 2 times 8 times 5k, plus the last term, which is 8, all squared. And last, you should have taken your first term, which is 4b, and squared it. Your middle term should have been 2 times the 2 things multiplied together, so 2 times 3 times 4b, plus the last term, which is a positive 3, squared. From here, we're going to go into factoring perfect square trinomials. You may use the diamond method if you'd like, or if you're able to recognize the shortcut, you may take a shortcut. So if you can notice here in this first example, 9 is 3 squared, or 3 times 3. And 6v is double that 3. So we can kind of undo this in the same way we've been factoring in our previous slides. I can take v squared, and instead of 6, I am going to add 2 times 3v, plus, and instead of 9, I am going to write this as 3 squared. So notice this term in the middle is 2 times v and 3. The base is on the outer edges of your expression. So when I factor this out, what I'm going to get is v plus 3 all raised to the second power. Again, since this middle term is double or 2 times the product of the bases of the first and the last term, this is a perfect square trinomial. So we can take a shortcut when we factor. To the right, this first term is a perfect square, so I'm going to write it as 2v all raised to the second power. And this last term you also should notice is a perfect square, so I'm going to write that as 5 raised to the second power. However, since this 20 in the middle is negative, I am going to make my base on my 5 negative as well. Now in the middle, you should be able to see that this is plus 2 times the 2 bases of my first and my last terms multiplied together. 2 times negative 5 times 2v. When I multiply all those together, I get my negative 20v in the middle. So when I factor this, all I'm going to do is take the very first base, which is a positive 2v, and add or subtract my very last base, which is a negative 5. And then square my binomial, and that is the factored form of your trinomial. I am going to do one more right below, and then I'll ask you to pause the video and do the next 3 on your own. 9n squared I see can be rewritten as 3n all raised to the second power. Positive 1 on the end is also a perfect square, so I can rewrite that as 1 squared. However, again, as before, since my 6 in the middle is negative, I'm going to make this base on the end negative. Now, in the middle, this negative 6 is simply positive 2 times my 2 bases, 3n and negative 1, multiplied together. So negative 1 times 3n. Plus, and I still have that negative 1 squared on the end. Now, since I have 2 perfect squares on the front and the end of my polynomial with 2 times their bases in the middle, to factor I simply take my first base of 3n and add or subtract my last base of negative 1 and square that binomial. Go ahead and pause the video and try the next 3 on your own. For the first, you should have had k plus 5 all squared. Down below to the left, you should have had 2r plus 3 all squared. And to the right, you should have 5r plus 1 all squared. Now remember, if you're not comfortable with this method, you may always factor by using your diamond. So that would be finding 2 terms that multiply to 9 and add to 6, rewriting this polynomial as 4 terms, and then factoring by grouping. That is absolutely an option. Thank you so much for watching, and I hope you enjoy the rest of your day.